students, today we are going to first map the whole chapter. That means we are going to understand the different types of motion which we have to study in this chapter, and we are going to talk about something from second chapter also, that is the topic force and laws of motion, because first chapter and the second chapter, they are interrelated with each other. So we'll have a brief introduction of second chapter also in while mapping the chapter. Force you have already understood, so it's not difficult to understand. So just have a look of the whole chapter. Here in this chapter, the different state of motion we are going to understand. For the first mapping, I have taken the situation in which the object is traveling on a very straight path. That means the object is not allowed to change its direction. Direction means it has to move on a very straight path, neither left nor right. Even he or she is not allowed to turn back also. So just have a look of this map. If I divide the state of motion broadly, we divide either the object at rest or in motion. Now, one thing I have written here, F is equal to 0. This means for this situation, the total value of force is 0. Then only you can observe this situation of any object. That means at rest. Now, for motion, second category is motion. Motion is further divided into two categories: uniform motion and non-uniform motion. Now, to get the knowledge of uniform motion and non-uniform motion, we have a next video. There you will be clear about the different types of motions. Now, for uniform motion, here also the force is not needed. Means overall the value of force should be 0. You can just take a note of that. For rest also force is not required, total force is not required, and for uniform motion also force is not required. Means not required means total value of force is not required. Now for coming to this category, non-uniform motion, I have written F is equal to K. K means some value of force is needed. It is essential. Otherwise, you cannot observe any object in the non-uniform motion. Now, non-uniform motion is further divided into uniform acceleration. The acceleration topic will deal in the next video. And then again there is a non-uniform acceleration. Now for uniform acceleration, I have written F is constant. As I said you, for non-uniform motion, some amount of force is needed. If that amount of force is constant, means the value of force applied is not changing, then we will observe the object in this situation. That means the object is moving with uniform acceleration. Means for uniform acceleration, the value of force needed should be fixed. It should not keep on changing throughout the journey. So as long as the force is constant, the object will be observed in uniform acceleration, and that is a very important part of your chapter, because most of the time we have to deal with this topic. Then for non-uniform acceleration, force I have written variable. That means amount of force is needed, but the value of the force, the magnitude of the force should keep on changing. Like on the road condition, you can see sometimes you accelerate your bike, sometimes you slow it down. That means there the amount of force changes, and according to the value of amount of force, the value of acceleration also changes, and that's why the body has different value of acceleration, and that we call non-uniform acceleration. We'll come to know about this motion in the next video also. Then for uniform acceleration, further we have divided into positive acceleration and negative acceleration. For positive acceleration, the direction of the force should be in the direction of the motion of the object. Then we find this positive acceleration. For negative acceleration, the force is applied opposite to the direction of the motion. So then we observe negative acceleration, just like when we apply brakes. When we apply brakes, and for this, when we apply accelerator in the vehicles, then we observe this kind of acceleration. Now for negative acceleration, two more names are there. One we call retardation, and or we can say deceleration. So this is the mapping of the chapter, and this whole situation we are observing, we are considering when the object is moving on a straight path. And at last in this chapter, we have to discuss about a motion in which the object is moving on a circular path with constant value of speed. So we'll come to know about that also. Here also force is needed. But how the force is required, how this type of motion is observed, when it is observed, that we'll come to know in the next classes. Thank you very much.